Hello and welcome to the third video in our Year 9 Indices series. Today we'll be talking about fractional indices, so stuff like cube roots, square roots, and etc. So let's dive straight into it. So first I want to start by using your calculator, find the value of 4 to the power of a half, 25 to the power of a half, and 64 to the power of 1/3. So what do we notice? Well, let's just do this. So 4 to the power of a half, put that in our calculator, is going to be 2. 25 to the power of a half, put that in our calculator, we're going to get an answer of 5. And 64 to the power of 1/3, that's going to give us an answer of 4. Now, what do you notice? Well, the main thing is that the square root of 4 is 2. The square root of 25 is 5. And the cube root of 64 is 4. And just to reinstate that, I want to write 4 is equal to 2 times 2. 25 is equal to 5 times 5. And 64 is equal to 4 times 4 times 4. So now let's move on to our next slide. What is the definition of fractional powers? Well, from the previous slide, we can deduce that a to the power of 1 on n is the nth root of a. Okay, so this is the formal definition. Now, what does the nth root actually mean? Well, it comes down to, if I am finding the fifth root, right? Let's say I'm finding the fifth root of 32, then I'm asking myself, what is a number that multiplies by itself 5 times is going to give you 32? And the answer to that question in this case is 2. Because if I do 2 times 2 times 2 times 2 times 2, so that's 5 times 2, right? That is going to give me 32. And so the nth root is basically, you have a number, multiply by itself over and over again n times to get the thing inside the root. So now let's move on to an extension of the index laws. Well, if we know that a to the power of 1 on n is equal to the nth root of a, in this case, they've just used p and q, so we're just going to use that instead. Obviously, a to the power of 1 on q is equal to the qth root of a. Well, using the index laws we've talked about in the previous videos, we can just say that a to the power of p over q is equal to a to the power of 1 on q to the power of p, because they're multiplied together. And we know that a to the power of 1 on q is, as we just talked about, the qth root of a. So therefore, a to the power of p on q is the qth root of a to the power of p. And that is what is shown here. Now let's talk about some easy examples. Let's evaluate 8 to the power of 1/3. Now, in terms of writing this out, powering something to the third is going to be cube rooting it, right? So we're trying to find the cube root of 8. Now you can chuck that into your calculator and get an answer of 2. And that makes sense because 2 times 2 times 2, there's 3 of them, is equal to 8. Now what about 1,000 to the power of 1 on 6? So if I put 1,000 to the power of 1 on 6 in my calculator, I'm going to get a weird number. I'm going to get 3.162277766, and it's going to keep going. Now, this isn't an exact value. This is really a decimal that can go on forever. So what is the exact value of 1,000 to the power of 1 on 6? The exact value is the 6th root of 1,000. And so that would be our exact answer. Let's move on to some more easy examples. So here we have evaluate the following in exact value. So here we have 3 to the power of 3 on 2. Now, using the law in our previous slide, we can say that this is the same as 3 to the power of a half to the power of 3. Now, we know that 3 to the power of a half is square root, right? So the square root of 3 to the power of 3. Now that is the final answer. Just another side note though, is that this is actually the same as just doing the square root of 3 cubed, which is the square root of 27. So just note that when we're cubing or when we're really powering a root anything, that number can actually go inside and it will still work. So with this one over here, we've got 81 to the power of 3 on 4. So what we're going to do is, once again, we're going to say this is the same as 81 to the power of 1 on 4 to the power of 3. Now, 81, the fourth root of 81. So that is what we get. Now, the fourth root of 81, if you put in your calculator, is actually an exact answer. It's going to be exactly 3. And that makes sense because 3 times 3 times 3 times 3. So 4 of them is equal to 81. So the fourth root of 81 is 3. So we have 3 to the power of 3, and that's equal to 27. So that would be our final answer there. But just notice how we can do it two ways. We can either leave the power outside or we can put it inside of the root. Now here we have an extension example. So suppose that we define S as the sum S equals 1 plus a half plus a quarter plus 1 on 8 plus 1 on 16 plus 1 on 32 and so onwards. Show that S on 2 equals S minus 1 and hence find the value of S. And question 2, find the value of the following. So I'm going to get you to pause the video and have a go at this extension example and then unpause so that we can go through the solution. Okay, so let's go through question 1. Show that S over 2 is equal to S minus 1. So first things first, we probably want to figure out what S over 2 is. So S over 2, remember we're just going to be dividing everything by 2. So if we divide everything by 2, we're going to get 1 over 2 plus, now what's a half over 2? That's a quarter, isn't it? So it's a quarter. A quarter over 2 is going to be an eighth. So it's an eighth plus 1 on 16. What's 1 on 16 divided by 2? That's 1 on 32. And you can see it's literally the exact same, right? So what is this? This is what S on 2 is equal to. So we can say that S is equal to 1 plus S on 2. Because S on 2 is this stuff here. And that is the same as the stuff over here. Now the question becomes quite easy. We just need to show that S on 2 equals S minus 1. Well, if we just move the 1 to the other side, we get S minus 1 is equal to S on 2. And you can see how we've successfully proven question 1. So that is the way we do question 1. Now moving on to question 2. Find the value of the following. 2 times root 2 times the fourth root of 2 times the eighth root of 2 and so on. So this is where we're going to be using our index laws, right? We know that 2 is just 2 to the power of 1. We know that square root of 2 is 2 to the power of a half. We know that the fourth root of 2 is 2 to the power of 1 on 4. And we know that the eighth root of 2 is 2 to the power of 1 on 8, and so on. So the pattern just keeps going. So we're going to get ... and keeps going. And you can see how using our index laws, we know when we're multiplying, we can actually just add the powers up. So this is equal to 2 to the power of 1 plus a half plus 1 on 4 plus 1 on 8 plus 1 on 16 and so on. So plus ... And remember, what is this? This is S, isn't it? It's S. So we have 2 to the power of S. Now the question is, what actually is S? Well, we can solve for what S is from this equation in question 1, which we already proved. If we know S on 2 is equal to S minus 1, then we can multiply both sides by 2. So we're going to get S on this side. We're going to get 2S here minus 2. So multiplied everything by 2. So S, 2S minus 2. I can move the minus 2 to the other side, so it becomes a plus 2. And I'm going to move this S to the other side, so it becomes a minus S. So I get 2S minus S. So I get 2 is equal to S. And so my final answer is S equals 2. So if I plug that in here, I get 2 to the power of 2, which is 4. And that is our final answer of what this is. So hopefully that made sense. Now, before we conclude the video, I do want to just quickly revise one concept here, which might not have been super clear. So we've talked about this case here, the qth root of a to the power of p. Well, just reiterating what I already said in the video, this is the exact same as just taking the qth root of a to the power of p. Okay, so just to reiterate, a to the power of p on q is equal to, there's two ways of writing this. It's a to the power of 1 on q to the power of p, right? And that's what we did before. So that's the qth root of a to the power of p. So that's option 1. Or the other way of writing it is it's a to the power of p to the power of 1 on q. Now remember, whenever we power something by 1 on q, we're just taking the qth root. So that's going to be the qth root of whatever's inside our brackets, which is a to the power of p. So these guys are exactly the same. Okay, so hopefully that makes sense. And that's going to be the end of our fractional indices surds video. We will be going through some more examples in the homework, so please stay tuned for that. But for now, we'll catch you in the next video, which will be talking about significant figures and scientific notation. Hope to see you there.